Good afternoon, everyone. So in last class, we have seen what is super engaging knapsack and how to calculate the value A set from a super engaging knapsack. Now we are going to see the algorithm for knapsack cryptosystem. So this algorithm, this knapsack cryptosystem algorithm divided into four major steps. First one is to generate a super engaging knapsack. Means that is from a given series of weight, we need to calculate the super increasing knapsack. In second step, we need to convert the super increasing knapsack to general knapsack. So in second step, what we will do, we will convert the super increasing knapsack to general knapsack. In third, the public key, that general knapsack is called the public key. And fourth, the private key is super increasing knapsack together with comparison with conversion factors. So first we need to find the super increasing knapsack. So for this, I'm going to consider an example. So let's consider our super increasing knapsack is 2, 3, 7, 4, 13, 57, 120, 250. So generally, if we talk about your university paper, means they will give the super increasing knapsack, and based on that, they will ask some calculation. So I will choose the super increasing knapsack is 2, 3, 7, 14, 30, 57, 120, 250. Now our next step is to convert super increasing knapsack to general knapsack. So how to calculate it? So for this, to convert super increasing knapsack into general knapsack, we need to choose two values. One is multiplier, that is m, and another one is modulus, that is n. So multiply here, multiply is denoted by m and modulus is denoted by n. We need to consider one condition that m and n should be relatively prime. Means the GCD of m and n should be equal to 1. If two numbers are relatively prime or co-prime, that means the GCD of that two numbers must be equal to 1. So here the m and n are relatively prime. That is m and n, the GCD of m and n should be 1. Next, n must be greater than sum of all elements in the super increasing knapsack. Another condition is the value of n must be the greater than the sum of all weight. That given weight 2, 3, 7, 14. N must be greater than the sum of all this number. So let's choose n equal to 41. M equal to 41. And n, first we need to add this value, and then after we can choose any value that should be relatively prime to m. So n here, so n is chosen as 490. It can be any value, but we need to consider that the sum of this value must be less than n, and that n and m must be relatively prime or co-prime. Okay, so we need to choose m and n. Okay, I choose m equal to 41 and n equal to 490. So now we are going to convert the given super increasing knapsack into general knapsack. So what we will do, we will multiply with m with given weight, and we will calculate the mod n. So here first weight is 2. Here we can see the first weight is here we can see the first weight is given in super increasing knapsack is 2. Then what we will do, we will multiply with 2 with m, that is 2m. So M, the value of M is 41. So 2 into 41. So 2 into 41 is 82. Now we will calculate mod with N. So here formula is weight Wi into N mod N. We have to put this value. So first W0 is 2, 2M, 2 into 41, 82 mod 491. So it will get, I will get the value 82. Then next 3 or 3 into M, 3 into 41, 123. Mod 491, that is 123. Then 7M, 7 into 41, 287. Then mod 91, 491. We will get the 287. Similarly, we will calculate 14 into M, 14 into 41. After solving this, we will get the value of 83. Then 30 into M, 30 into 41. After solving this, we will get the value 248. Likewise, we will calculate for all weight. At last, 251 into 41. And after solving this, we will get the value 471. Okay. So clear. So the value what we have received 82, 183, 287, 83, 248, 70, 373, 10, 470. This we will write in a set, and that resultant is called the general knapsack. Here we have written 82, 123, 287, 83, 248, 373, 10, 470. So what was our second step? To convert the super increasing knapsack into general knapsack. So this resultant is called general knapsack. Hope you are getting. Okay. Now third. In third step, it is mentioned that the general knapsack is the public key. So this is the key which is going from receiver end to the sender end. So it is a public key that will send by the receiver to the sender. Now sender will receive this message, receive this public key and encrypt his or her plain text to convert into ciphertext. So this is the public key. The general knapsack series is a public key. So it is a public key. Now next private key. The private key is the super increasing knapsack together with the modular inverse of the conversion factor n. So what we had super increasing knapsack. Super increasing knapsack we have a British 237. It is a private key. So this is the private key. 237 14 30 57 120 251. And with that modular inverse of conversion factor. So M, what we have considered M we have considered it as 41. So what we will do, we will find the inverse of 41 of modulus 491. So here we have calculated 41 inverse. This is the formula M inverse mod N. M is here, M is 41 inverse, and 41 that inverse we have to calculate in mod 491. After solving this, you can try using Euler's multiplicative inverse to find Euler's using Euler's theorem to find it, or you can also use extended Euclidean algorithm. So after solving this, we will get the value of 12. So suppose Alice wants to send plain text is 150. So first step, Bob need to generate the key. Then Bob will send the public key to the Alice. And now after receiving the key, Alice will encrypt the plain text using the public key. And after receiving that ciphertext, the Bob will use his private key and decrypt the message. So suppose Alice want to send the message M equal to 150 for Bob. So first we need to convert the 150 into binary. So hope you all know how to convert decimal to binary. So after converting 150 to binary, you will get 100 10110. Here public key, what we have already calculated, is 82 183 287 like this. Now we need to calculate the ciphertext. Ciphertext in knapsack. See that equation already we have studied. A0 W0 plus A1 W1 and so on. A7 W7. We have total 7 bits of that. So we will get the 82 into 1 plus where we have seen 1 means 1 will multiply with that number, or we have to consider that weight only, that public here. So 82 plus 83 plus 373 plus 10. So we will get C equal to 548. So this ciphertext, now this ciphertext will be sent to the receiver. So receiver will receive C equal to C48, 548, and then Bob uses his private key to find the plain text. So first, how to decrypt? So this is the this is the process for encryption. This is the encryption, and for decryption, he will do C into M inverse model. C into M inverse model. So we have M inverse model we have already completed, that is 12, and C is 548. So 548 into 12 mod 491. After solving this, we will get the value 193. So Bob solves and get the plain text is 193. Now Bob will convert this plain text, this decimal into binary. Decimal into binary. So 193 will converted into 100 10110. Okay. So after calculating C into M inverse mod N, that is 548 into 12. 12 we have already calculated, means that is 41 inverse mod 591, no 491. So it is 12 and 548, that is 193 we have received, we have find the value C into M inverse. So Bob solved the super increasing knapsack for 193. So what Bob will do, Bob have private key, that is super increasing knapsack, and based on this calculated value is 193. So again we will choose, we will compare with 193 with 251. So it is 193 is less than 251, so it should be 0. We can't consider 251 because 251 is greater than 193. We have to find the value of value which one should be 193. So it is 0. Then we will compare 193 with 120. So 120 is greater than 193, so it should be considered. So the value should be 1. Next, now updated 193 will update to means 193 minus 120, that is 73. So 73 is compared with 57. So we can consider 57. So it should be 1. Now the updated value is 73. Wait, I will solve this function. Here sum equal to 193. So first we calculate 193 with 251. So 193 is less than 251, so we can't consider this. So the bit value is, next we will consider 193 with 120. So 193 greater than 120, so we can consider this bit value is 1. Now the updated SC is updated 193 means 193 minus 120, that is equal to 63. So now we compare 63 with the previous value, that is 57. 63 is greater than 57. We are comparing with this value, private key. Okay, we are comparing with private key. We are comparing with private key. We are comparing with this private key. So bit value should be 1. So updated value is 63 minus 57. So it is 6. Now we'll compare with the previous value, that is 30. So 36 is less than 30. So bit value should be 0. It can't be, there is no update in as value. So now we compare 6 with yes, 73. 73. 73. So yeah, value will be 16. 16. Now next we will compare with previous value, that is 14. So 16 is greater than 14. So bit value should be 1. Okay, now updated as value will be 16 minus 14. That is 2. Now we compare 2 with the previous value, that is 7. So 2 is less than 7, so bit value will be 0. Okay. Now we will compare 2 with 3. So 2 is less than 3, so bit value will be 0. And now next is and last one is 2. Greater than 2, so bit value will be 1. So what we have get the bit value 1 0 0 1 0 1 0 0. So 1 0 0 1 0 0 1 0 0 1 0 1 1 0. So this is the calculated A based on the given super increasing knapsack. That is private key for the receiver. Hope you are getting this one. Next. So if we convert this boundary into decimal, we will get 150. If we convert this boundary value 1001 0110, then we will get the 150. So this was the message that was sent by the sender. So this is the process of decryption. So this is all about the knapsack cryptosystem. For practice, we can consider an example. Suppose knapsack private keys, knapsack private keys, super knapsack private key is also a super increasing function. So if super increasing function is given or knapsack private key is given, both are same thing. Is 3, 5, 10, 20. Suppose this is the knapsack private key, and m inverse. So here I am writing it as 1 to the power minus 1 equal to 6. It is also given. For modulus, and n is also given, n equal to 47. N equal to 47. So these are the given. So now we have to calculate. The plain text. You have to calculate the plain text for the ciphertext. Ciphertext equal to 20. Okay. So we need to find the plain text in binary. And same, we need to find the plain text. First, into 29 in binary. Okay, and third, find n. Find n and try. This is question number. Okay, this is question number. Okay. Another question you can solve. Latest. Okay. Question you can solve. Suppose that it is just 7, 19, 79, 7, this is the super intelligent tuple. So, and consider m equal to 37 and n equal to 9. This all are given. This all are now we need to calculate. Suppose okay, m equal to 37, n equal to 30, 900. Net text is 103. Okay, so we need to find the text. Also, after generating ciphertext, try to calculate the plain text using private key. Okay, try this question. First, try question number 2, and then you can try question number 1. Okay.